of figure 7.4a, when operated with VDD is equal to 2 voltage, is found to have a maximum small signal voltage gain magnitude of 14 voltage per voltage. Find overdrive voltage and drain source voltage for bias point Q, at which a voltage gain of minus 12 voltage per voltage is obtained. Okay, so we have the available information for us is VDD, that is equal to 2 voltage, and also we have the maximum small voltage gain, that is AV, that is 14 voltage per voltage. Okay, these two are given, and they are asking us to find V overdrive and VDS for bias point Q. So this is at Q we had to find, at which a voltage gain of minus 12 voltage per voltage is obtained. So they are also given that at that point the voltage gain at the Q is minus 12 voltage per voltage. Okay, so these are the information available. These are what we have to find. Now let's see how we can find it. So when we consider gain, there are two equations we can use. One of the equation is okay, and also this is mentioned maximum, and maximum gain, there is an equation for maximum gain, AV max, that is equivalent to VDD minus VDS at point B, that is this, and also that one divided by V overdrive at point B divided by 2, and for the maximum gain we have to this V overdrive and VDS are equal for the maximum gain. So consider that, consider VDS at B is equal to VOV at B for maximum gain. So if that's the case, then we can replace the VDS-B with VOV. So if we do that, then this is AV max is equal to VDD minus V overdrive at B divided by V overdrive at B divided by 2. Here we know the maximum gain, that is 14, and VDD also provided in the question, that is 2, minus VOV at B, and then VOV divided by 2, VOV at B divided by 2. So from this one we can solve for VOV. If we solve for that, we will end up getting we will end up getting 2, actually not 2, it is 0.25 voltage. Okay, now we have this. The next thing is we are particularly interested in finding VOVQ. So why this one is useful is because there's an equation for the gain again, that is given by AV is equal to minus KN VOV RD, and this VOV depends on which region you are put in. Like for VOV at point B, that's going to be different. At VOV at point Q, that's going to be different. But the thing that will be remaining the same is KN and RD is same everywhere. It doesn't matter B or Q, it's going to be same all other places. So if we can use this equation to solve for the KN RD. And to find out the KN RD at the point Q, we have to substitute the gain at the Q as well. then only we can get it. Okay, so let's put the equation here. AV okay, maximum gain given to be minus 12 voltage, and this one is minus 40. Actually we had to put 14 here. This is 14, and yeah, we had to just put the 14 and solve for it. So gain is basically kn, because k and RD is going to be same everywhere, so you had to put the gain related to this VOV. We got it from the B location, so we had to use the same gain here as well. So this one is VOV at B, and then RD. So here we can solve for the RD. This is minus 14, and then this one is minus kn RD multiplied by the VOV B, that is we calculated to be 0.25, and solve for k and RD. You will end up getting 56. Okay, now we have the k and RD. Now to find out the overdrive voltage at Q, you had to just use the same exact equation, but this time you use the gain of minus 12. So AV minus k and RD VOV at Q, this is what you are trying to find, and this is equal to, okay, let me put AVQ as well. AVQ is equal to minus k and RD VOVQ, and AVQ we already know that's to be minus 12, and that is equal to minus k and RD, that is minus k and RD we found out to be 56, and we are trying to find out the VOVQ, and if you solve for VOVQ, that one comes out to be 0.214 voltage. Okay, this is the required thing. This is one of the required thing in the question. They ask for this, and also they require what is the VDS value. To find out the VDS value, we can use this equation again. Okay, this time we just put AV because AV max is happening at this point, but this gain equation is we can use anywhere. So if we use this gain equation, AV, that is equal to VDD minus VDS divided by V overdrive. Here we are interested in the Q. V over Q divided by 2, and this one here we are going to use the gain at the Q. The gain at the Q, we know that to be minus 12, and we know the VDD, that is 2, and we are trying to figure out VDS at Q, and V overdrive we just calculated, that is to be 0.214 voltage, so that one divided by 2, and solve for the VDS. You will end up getting VDS at Q to be 0.714 voltage. Okay, these are the two things required. We need to find the overdrive voltage at point Q. We need to find out the VDS at point Q. We just did both of them. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next